Let's look at another type of empirical formula. In this one, it says 8.619 grams of chromium. So you have some chromium metal, and say you burnt it. Whenever you burn something, mostly you're reacting with the oxygen here. And say I produced 12.00 grams of a chromium oxide compound. And determine the empirical formula. So chromium is one of those transition metals that can form more than one type of cation. So you got to figure out what type of cation did this one react with the oxygen. Let's write down what the reaction is. So I have chromium. It reacted with the oxygen here, and I formed this chromium oxide compound. What they're basically saying is, I got 8.619 grams of chromium, and I ended up with this chromium oxide compound. Now, it has to weigh more now than the chromium initially because it combined with the oxygen. And so it does. It's 12.00 grams. 600 grams of this compound. So a couple of things. To get the mass of oxygen, well, it's only the difference between the mass of chromium you start off with and then the mass of the chromium oxide. So the grams of oxygen and I think that's going to be 3.982 grams of oxygen. A couple of things when you're doing this. Always convert the mass into grams. One thing to notice that even though oxygen is diatomic here, when I look at the mass of oxygen, we're just going to do the mass of one oxygen. So I have 3.982 grams of oxygen. I'm going to convert it to moles. So for empirical formula, always convert the mass to moles or percent to grams to moles, etc. So I'm going to divide by 16. It's going to give me 0.2489 moles. Now I'm going to do the same for chromium. Get the grams of chromium and convert to moles. So empirical formula, always convert grams to moles. So I'll put 2 here. Look up the molar mass of chromium, which is 52. It's going to be 0.1658 moles of chromium. So I've written the moles of chromium and the moles of oxygen as a subscript. We divide by the lowest number of moles. So I'm going to divide by the 0.658. So that chromium is going to be 1. Couple of things. We're supposed to round off to the nearest whole number. But if you do this division, oxygen is going to be 1.5. So it's in between. So we can't just round off to the 2 or the 1, etc. We want to get rid of that 1.5. The way to do that, we multiply everything by 2. So our empirical formula now is 2 chromiums and 3 oxygen. So the only 2 scenarios you can get for empirical formula is that either it's close to the whole number that you can round it off, or it's right in the middle and then you just multiply everything by 2.